camera. Okay. Chapter 2, polynomial equations and factoring. So there's going to be a lot of key terms here. If you've taken a look at the notes already on Google Classroom, you'll know there are a lot of key terms in this that we're going to be familiarizing ourselves with. So just bear with me. It shouldn't be overly difficult, but I wanted to make sure I spend the bulk of this time talking about the key terms you will be seeing. Okay, so before we get too deep, I wanted to kind of break down the name of our unit because it's just basically a lot of syllables, right? So first off, polynomial. Polynomial quite literally means many terms or many names, okay? For us, that's going to be stuff like this. Okay, you've all seen these before. Basically, long sentence equations where it's adding and subtracting these various items, these little smushed together items that we're going to call monomials. Okay, so I'll break that down in a second. But a polynomial is just going to be like a long sentence, a collection of singular terms. Equations, this is going to imply that at some point we're going to be solving for given variables. We will be getting like x equals and then some set of values. Okay, and then this term factoring is something we're actually going to be exploring a little bit later in this unit. You will all be familiar with the operation of distribution, where if I multiply something by a parentheses, I'm distributing it throughout that parentheses. Well, factoring is going to be the inverse of that, where basically instead of multiplying through a parentheses, I'm pulling a number out and creating a parentheses. So again, we'll get into that a little bit later in this unit. For right now, we're going to focus on our regular polynomial equations. All right, so section 1, adding and subtracting polynomials. Okay, so again, there's our polynomials term. We're going to be dealing with stuff like this, and we're essentially going to be adding and subtracting those things together. This can all basically be boiled down to, or at least this part right here, the adding and subtracting, it can be boiled down to collecting like terms. Okay, and the last two examples we do today will be an example of that. But first, I wanted to talk about some of our key terms. So first off, what is a monomial? Monomial is just going to be, this is like a very formalized definition. Each of these are examples of monomials. Okay, these are not the only three. So basically any number, decimal, fraction, whole number like this guy, that's a monomial. Okay, technically there is a variable there. It's just that the variable is raised to the 0 power. Okay, and that's going to be confusing for us right now. Let's just focus on the fact that all numbers are some form of a monomial. Okay, something that we're familiar with, like 3 times x. 3x is a monomial. That's not two monomials. This is a single monomial. Okay, and the reason why it's in the definition is it involves a product or multiplication of numbers and variables. If it can be smushed together into a single term like this, 3 times x or 3x, it's a monomial. All right, and they can of course get a little more complex, like this guy. 1/2 AB squared. Again, because it's a series of multiplication, or it can be smushed into a single phrase like this. Okay, that's still a monomial. It's just a more complicated monomial. 1/2 times A times B squared. Again, since it's a product or multiplication, it's a single term. Okay, now I can combine these monomials together with addition and subtraction to create a polynomial, like here in the margin. Okay. These are just specific names to polynomials. Binomial meaning 2 terms. Okay, you'll be familiar with this from our y equals mx plus b stuff. Okay, you dealt with binomials all the time. Trinomials just means there are 3 terms. You could end up with lots of different variables. Doesn't have to all just be x. Okay, we'll deal with that stuff in here. Okay, but that's what a monomial means. You're going to be asked about monomials. You'll be asked about polynomials, right? So there are a couple of terms that we're going to have to deal with as far as like what some of these questions are going to ask you about. And the first of which is going to be the degree of something. The degree of something. The degree is actually going to refer directly to the exponent value that we see in a given monomial. Okay, so I took those same 3 examples and we're going to talk about in terms of degree for each of those terms. So if you have just a number, okay, the degree has to do with the exponent over a variable. Okay, so in other words, we're looking for like x's, y's, a, b's, like a letter, right? So a number is not a variable. This is what we would call a constant. 10 is 10 is 10 is 10. All right? A variable can be anything. But there is no variable in this case, so that's be what we call degree of 0, right? Because there is no variable, right? So what about 3x? 3x does have a variable. That's x. 3 is a constant. 3 is always 3. But x can be representative of anything, really. That's why we call it a variable. But now I'm going to focus on that variable and identify what exponent value is up there. Now, the reason why it's a degree of 1 is because technically there is an exponent here, and we've mentioned this in the previous unit as well. A variable where there isn't an exponent, there is one there. It's just we don't write it. It's 1 because x to the 1 power is just x. So if you don't see an exponent, it's an exponent of 1. All right. The more complicated one here, 1/2 ab squared. Now, here's where you really do have to pay attention to what this formalized definition says. Okay, it says it's the sum or addition of the exponents of the variables in the monomial. In other words, I have to first identify how many variables I have here. There are actually 2, A and B, right? And now that I've identified my variables, I have to add together their exponents. Well, A, just like x in that previous example, has technically an exponent of 1. All right, so that has an exponent of 1. Now the b is squared or has an exponent of 2. So what I'm going to be doing for the degree of this monomial is I'm going to be adding together the exponents to find my ultimate degree here. So where did the 3 come from? A has an exponent of 1. B has an exponent of 2. The 1 plus 2 gives me 3. 1/2 is not a variable. 1/2 is a constant. That's why I don't have to worry about anything with that exponent. Okay. So again, degree of a monomial has to do with adding those exponents together. All right. So in this next section, right here, so polynomials, again, are just collections of monomials, whether it be one or several. Each of these is an example of a polynomial. This one is a binomial, again, a la like y equals mx plus b. This one's obviously a lot longer, right? But both are polynomials. They're collections of monomials. 5x and 2 are both monomials. 12a cubed, 8a squared, negative 2a, 7. Each of those is a monomial. This is just a 4-term polynomial. Okay? And so I'm going to break down what you're going to see for your first several problems. You're going to be given some polynomial, whether it's in a specific order or not. And then you're going to be asked a couple of questions about them. First, you're going to be asked to put them in standard form. So I'm going to talk about this in just a second. And then you're going to be asked about degree, like we've just talked about up here. You're going to be asked about the degree of a polynomial and the leading coefficient of a polynomial. Okay, so I'll break both those down in just a second. Let me talk about what's here in this margin first. All right. So one of the first things you're going to be asked to do with any given polynomial is you're going to be asked to write it in standard form. Well, what is standard form? For us, it's essentially going to mean descending order. What is descending? The exponents. They'll use the term degree descending, but the exponents for us are essentially is what it's going to be. So for instance, this longer one right here, you'll notice that the biggest exponent is that a cubed, a to the 3rd power. And descending order means that as long as I have like a decreasing value of exponent as I work from left to right, like reading a book, then it's in descending order, also known as standard form. Technically, this is also in standard form in descending order because the largest exponent here is x to the 1st power. And then there is no x or power in this case, so that'd be a degree of 0. So this is still in descending order. It's just a lot shorter order. Okay. All right. So we'll deal with this in an example upcoming. But now I want to apply these 2 examples to how do I find the degree and the leading coefficient. So again, degree is similar to what we talked about right here. I'm looking for a variable. I'm looking for the exponents. So for my more simpler binomial here, what's the degree of this? I'm looking for the variable, this first term. For both of these, degree and leading coefficient, I'm only going to really focus on this first term. We'll see this in example form in a minute. But so this 5x, I'm only going to care about this 5x. I'm not even going to care about that 2. But in this 5x, the highest degree in this polynomial, this binomial, is the x to the 1 power. meaning that this is a degree of 1. This is a first degree polynomial. This longer one here, again, there are a lot of terms here, but I'm only going to focus on this first one. Okay, so the degree of the greatest degree of its monomials, I'm only going to care about this leading monomial, now that's in standard form, 12a cubed. And the highest exponent here is 3. Now there's no other variables, so I don't have to worry about adding any other exponents. But in this case, the degree of this term is 3. Okay. It doesn't matter that it has other exponents in this phrase, because again, these are other monomials that are added or subtracted to that leading monomial. That's the only one I'm going to care about. Right? Now, what's a leading coefficient? Actually, more basically, what is a coefficient? So a coefficient, for those that don't recall, this is a term that was actually introduced probably in middle school for you, but a coefficient is simply the number multiplied by a variable, or all the numbers within these polynomials. So for instance, in this monomial here, the coefficient is 12. It's the number multiplied by the variable. In this monomial, the coefficient is positive 8. Positive 8 times a squared. In this monomial, the coefficient is negative 2. In this monomial, the coefficient is 7. There's just no variable it's multiplied by. In this binomial here in this first monomial, the coefficient is 5, and there's one of 2. So the coefficient simply is the number that's multiplied by a variable, okay? And so the leading coefficient only refers to, again, the first term in either of these polynomials, okay? So in this binomial here, what's the first term, the first coefficient? That'd be 5. And this one right here, it'd be 12. So why do they bother asking us about these two things? When it comes to graphing complex polynomials, and you're not going to really be pushed into graphing polynomials until Math 3. But for right now, suffice it to say that if you were to graph either of these, whether it's a line like this guy or a cubic function like this guy, the biggest factor into what's going to determine its shape has to do with the leading term, the leading monomial in both cases. Okay, for a line, the biggest determining factor of its shape is its slope. That's the m times x, or the 5 in this case. That determines the shape of the graph. In this case, you don't know this about cubic functions yet, but this will have to do with about the rates of change in that curve. In this case, that 12 will directly determine it. The a cubed determines the shape of polynomial it is. And again, you don't need to know this yet because this is more of a Math 3 concept, but it will determine that it's a wavy shape based on the type of polynomial it is, the fact that it's a degree of 3. In this case, the fact that it's a degree of 1 makes it linear. The fact that it doesn't have any x squareds or x cubed or anything means it's going to stay linear in nature. Okay. Now, again, that's like a preview into much further ahead mathematics, but that's why they ask us about these first. To just get our feet wet, first let's identify those values. All right, let's jump into some examples, see how these are actually applied. The key terms take up a lot of time, I know, as far as the descriptions, but the comfort will be that that the examples and the problems themselves will go by really fast. All right, so let's deal with our first one here. This is very typical of your first several problems you'll get in this assignment. You'll be given some polynomial like this guy, 15x minus x cubed plus 3. It's going to ask you to write it in standard form, which again for us means descending order. And then you're going to be asked to identify the degree and leading coefficient of the new polynomial now that's written standard form. So let me run through that real quick. This illustration tends to be more valuable than the stuff we just did, but let me burn through it. All right, so in our problem we had 15x minus x cubed plus 3. This is a trinomial, 3 separate monomials in this polynomial. And I'm going to demonstrate something that's very important to understand about polynomials. Okay, this 15x is a monomial. Negative x cubed is a monomial. Positive 3 is a monomial. It can be helpful to do this. You don't have to do this on every problem, but this is helpful for an illustration, so I recommend you put this in your notes. I'm going to basically box up each of these monomials to illustrate something. Okay. So here's my trinomial. Nothing's changed with it yet, but what I've done is I've boxed up each of the monomials here. 15x, negative x cubed, and positive 3. The reason I did that is because I'm going to ultimately demonstrate that I can rearrange this in any way, shape, or form that I want. I can throw this negative x cubed in front. I can put this positive 3 in the middle. It actually doesn't matter the order as long as I keep the correct coefficient in front of each term. Because it's being added or subtracted, I can rearrange this however I want as long as I keep the coefficient. And that's important because I can rearrange this into a descending order. Namely, here's my highest degree term. This can go first. So I can rearrange this with a negative x cubed first. Notice that the negative stayed attached to it. Then this 15x would be the next highest degree term. And so I can put this positive 15x next. And finally, my lowest degree term is just the number 3. Typically, there will always be some just number value, a degree 0 term at the back end. Now, for the record, this is the exact equivalent of the original polynomial they gave me. It's just rearranged. Okay, nothing changed in any values. Okay, but now that's in standard form. The reason why this is more valuable is because, again, this first monomial, this leading monomial in standard form, is going to give me the most information. So the first question asked me to first put in standard form. We've achieved that. Now what I'm going to focus on is in this first monomial, the block that I moved out in front, right? And so now when it asks me about degree, I'm going to focus on the exponent value for my monomial. I'm not going to care about the other ones. So the degree here would be 3. The leading coefficient, again, a coefficient is the number multiplied by a variable. Again, I'm only going to care about my first term. I'm not going to care about these two guys for this part of the question. Leading coefficient is what number is multiplied by my variable. In this case, it's just a negative, and so this is about as tricky as it gets. This would be a negative 1. Some people get confused if they don't see a negative sign there. Okay, technically speaking, there is a number multiplied by the x cubed in this case. It's just a positive 1. Okay, so when it asks for leading coefficient, there is always a number multiplied by the variable. It just might be 1. Okay, all right, I'm going to erase and move on from that. You will get several questions that ask that kind of phrasing, like, hey, here's a polynomial, rearrange it into descending order or standard form, and then it'll ask you about degree and leading coefficient. All right, so now let's jump into the actual namesake for this section, finding the sum or difference or addition, subtraction of polynomials. And this is pretty much what you'll see. This is pretty representative of what you'll see on a test as well. Here's a polynomial. They put it in parentheses for a reason. I'll break that down in a second. But here's a polynomial, and I'm either going to add or subtract some other polynomial. Okay? Now, the reason why they put it in parentheses is because you're basically taking this polynomial and adding in another object of polynomial. Okay? Now, that's going to be important, particularly for this one with subtraction, but I'll break this down on my solution sheet so you can kind of see what's happening. Again, the solution sheet is also uploaded onto Google Classroom, so you can track it down there. Okay, so here's our first problem where I'm combining two different polynomials through addition. And like I said at the very beginning of this lesson, this is basically just going to break down to collecting like terms. Okay, one reason a polynomial stays a polynomial is because, like, these x cubeds can't combine with the x squareds. The x squareds can't combine with the x's. So it stays separated, right? So when I'm adding in some other polynomial, I have to keep families together, basically, right? So my x cubeds, x to the third powers, can only combine with other x to the third powers, okay? And so my 2x cubed can only combine with the positive x cubed. My x squareds, my x to the 2 powers, this negative 5x squared, can only combine with another x squared over here, which that positive 2x squared right there is what those two will combine with, right? The positive x right here can only combine with other x's, but there are no other x's in either, so the positive x will just stay positive x. Same thing with the -1 on the back end. It's the only whole number in here, or number in general. And so that's going to stay just -1. And so it really just turns into collecting like terms. Okay. And when it comes to subtraction, there's only one twist here. So when I take some parentheses of a polynomial and I subtract another parentheses of a polynomial through subtraction, technically what's going to happen is that this subtraction is distributing a negative throughout whatever's being subtracted. Here's what I mean. So this 4n squared can only combine with other n squareds. Well, it's going to combine with that -2n squared there. So if I were to read this as it's written, I'd have 4n squared minus -2n squared. But as you may be aware, if I subtract the negative, that's going to turn into addition. So another way to think about this, and here's my advice on these subtraction problems, because these are about as tricky as they get. It's still a combination of like terms, but the trickiest it gets is with these subtraction problems. My suggestion, just distribute the negative throughout the second parentheses. And how do you do that? Just flip each sign. So a -2n squared becomes +2n squared. The -2n becomes -2n. The -4 becomes +4. Okay, so my suggestion on your subtraction problems, when you subtract a polynomial, just flip each sign in the polynomial, and now it's no different than the addition problems. It'll just be a sentence with all the correct coefficients, and then you combine like terms. Variable squareds with variable squareds, single variables with single variables, and then numbers with numbers, that sort of thing. Okay, so let me go ahead and stop recording.